Welcome to a lesson on the addition and subtraction of polynomials. The goals are to add and subtract polynomials and also to check our work using the graphing calculator. In order to add polynomials, we have to combine our like terms and then write in descending order. Let's start by identifying our like terms. Here's an x squared term, and here's an x squared term. Here's an x term, and here's an x term. And then we have two constants. Remember to combine our like terms. Since both of these contain x squared, we could factor that out and we're left with 4 plus 2. To combine the x terms, we would factor the common x out and be left with 8 minus 5. And then lastly, for the constants, we'd have negative 7 minus 12. So this simplifies to 6x squared plus 3x plus a negative 19, or just minus 19. Now remember that we often skip this middle step, but it is a distributive property that lets us combine like terms. Now we can check our work with the graphing calculator. And the way we do this, if we press y equals, type in the original addition problem into y1, and type in our sum in y2, we can use the table feature to check our answer. The way we do this, if we press second graph, notice that for whatever x value we choose, y1 is equal to y2. So what that means is that those expressions must be equivalent if they're producing the same output for different values of x. Let's try a couple more addition problems. First step is to identify our like terms. We'll start with the highest degree terms first. Here's a y cubed term, and here's another. Here's a y squared term, and here's another. And here's a constant, and here's another. So to combine our y cubed terms, we need to add or subtract the coefficients. So 24 plus a negative 6 would equal 18. So we have 18y cubed. I'll cross these off to keep it clear. Next we'll address the y squared terms. Notice the coefficients of the y squared terms. We'd have negative 7 plus 7. That would equal 0. 0y squared would be 0. So these simplify out because they are opposites. And lastly we have 5 plus 5, which would equal 10. Now you can add polynomials instead of horizontally in the vertical format. Let's go ahead and do our second example that way. So we line this up such that we would have t squared minus t plus 5 plus 7t squared minus 4t minus 20. And when you write the problem in vertical form, you do want to make sure your like terms line up. Notice we have the t squared terms here, the t terms, and the constants. So this may help you keep track of your terms. So when we combine our like terms vertically, we can see we'd have 8t squared, negative 1 minus 4 would be negative 5 or minus 5t, and then 5 plus negative 20 or 5 minus 20 would equal negative 15. So you may actually prefer the vertical format because it is nice to be able to line up your like terms. When you do have your polynomials lined up vertically, it does seem like it's easier to add them and keep track of your terms, so you may want to try it. Okay, let's go ahead and talk about subtraction now. Subtracting polynomials is a little bit more involved because the first step is to rewrite the subtraction as an addition problem. Remember, to change subtraction to addition, we must add the opposite or additive inverse. So going back to arithmetic, remember that if I had 5 minus 7, I could write that as 5 plus negative 7. Or if I have 5 minus negative 3, that's the same as 5 plus 3. So once we rewrite the subtraction as addition, we combine like terms and write in descending order. So the first step is to change this subtraction to addition. Now remember, we're subtracting all three of these terms. So in order to change this to addition, we have to add the opposite of each of these. So the result would be plus a negative 2x squared. Subtracting a minus 5 is the same as adding a positive 5x. And subtracting a minus 12 is the same as adding a positive 12. Notice the sign of each of these changed when we changed it to addition. We had a positive 2x squared, now we have a negative 2x squared. We had a minus 5x, now we have plus 5x. We had minus 12, so now we have plus 12. Now we'll combine our like terms. Let's start with the x squared terms. 4x squared plus a negative 2x squared. That would give us 2x squared. And 8x plus 5x equals 13x. And a negative 7 plus 12 would equal plus 5 or positive 5. Let's go ahead and check this one on our graphing calculator as well. So we'll type the original problem into y1, type in our difference in y2, and using the t-table compare y1 and y2, and again we see that y1 and y2 are equal for different values of x, therefore we can assume we have subtracted correctly. Let's take a look at a couple more examples. When subtracting polynomials, it might be more beneficial to write it in vertical form. So let's go ahead and try one in this way. I noticed when I wrote this I left some room because I noticed there was no x squared term or x term in this first polynomial. And when I write the second, I'm going to line up the like terms. So I'll write the 4x cubed here, minus 5x here, and plus 9 here. Okay, so I've rewritten this in vertical form. It's still a subtraction problem, but I did line up the like terms. So now if I want to change this to addition, I can do that as long as I change the sign of each of these. So if I change this to addition, this would become a negative 4x cubed, this would become a positive 5x, and this would become a negative 9. Now I can just combine my like terms vertically to obtain 6x to the fourth. Here we'd have negative 1x cubed, or negative x cubed, plus 5x. And negative 1 plus negative 9 would be negative 10, so we write down minus 10. Remember, minus 10 is the same as adding a negative 10, but this form is preferred. This one was kind of involved, so let's go ahead and go back and check it on our graphing calculator. It does take a little bit of time to type these in, but it is worth verifying we've done it correctly. Okay, so to save some time I've already typed everything in. Let's go to our table, second graph, and make sure that y1 and y2 are the same, and we can see that they are. Let's go ahead and try one more. Again, I do prefer the vertical method, especially for subtracting, so I'm going to go ahead and set it up that way. Again, I noticed there was no y term, so I left an extra space because there is a y term in the second polynomial. Make sure we line up the like terms. Okay, so I have the same subtraction problem in vertical form. I'm going to change this to addition now, but when I do that I have to add the opposites. So if I change this to addition, this would become negative, this would become positive, and this would become a negative 2y. Now we can combine our like terms vertically. Remember, this would be a minus 1y cubed. So 1.5y cubed minus 1y cubed would be 0.5y cubed. 4.8y squared plus 1.7y squared would equal 6.5y squared. There's no other y terms, but instead of writing plus a negative 2y, it's more common to write minus 2y. And there's no other constants, so we write plus 12. I hope you found this video helpful, and thank you for watching.